Okay, so we're moving on to our final method for solving systems of equations. We've graphed, we've used substitution, and now we're going to use elimination, right? So we're getting down to it where you're going to be able to look at a set of equations that's given to you and be able to say, oh, I'm going to choose to graph those. So let's just do a quick little review. Graphing is best if you have an equation like this, a systems of equations. So if I give you these two equations and say find the intersection, you would say give me a piece of graph paper because that's in slope-intercept form, the numbers are manageable, I'm going to graph them and see where they meet. I can't imagine you would want to do substitution with that, with a fraction. You could, but you probably wouldn't choose it, right? Substitution would be maybe y is equal to x plus 1 or 2x minus y is equal to 6. This would be a good candidate for substitution because y is already solved for. You could put it there and then go from there, okay? So today we're going to use something called elimination, all right? So if I give you this system of equations, 2x plus 3y equals 11, negative 2x plus 5y equals 13. And if I were today, knowing that you've only learned both of these ways, ask you to solve that, you would look at that and probably groan. You would go, oh gosh, none of them have a coefficient of just 1. Even if I solve this one for x and divide these by 2, I'm going to have decimals. Nothing looks good. Even solving it for y to graph it. So I am now going to show you a method called elimination that is going to take that from what you would think is the hardest problem to the easiest problem. Okay? So kind of off to the side here, you may or may not know that you can add equations. What do you mean you can add equations? Just like you can add expressions, you can add equations. Just like you had a little expression like this that you would set up vertically, and 6 plus 4 is 10, you can do the same thing with equations. So I want to take 2x plus 3y equals 11 and add it to negative 2x plus 5y equals 13. And watch how awesome this is. Yes, I know, I see people's faces. So when I go, first of all, you notice they're both in standard form. And you notice that the x's line up with the x's, the y's with the y's, the constants with the constants. And what happens when I go to add a negative 2x and a positive 2x? They cancel. And what am I left with? 3y plus 5y. And 11 plus 13. And divide by 8. And what? I already know my y value? Yes. So here's what we're doing. Remember how I took the highlighter out for substitution and I highlighted the one that was ready? This one's already ready because the x's were already set up to be eliminated. We're not even saying cancel because the method is called elimination. I am literally picking a set of variables, either both of the x's or both of the y's, and eliminating them all together, just like that. That's going to leave you with one variable left to solve for, and now you know half of your answer. And the beautiful part about elimination is step 2, to find your second point coordinate is exactly the same as substitution. Once you know one, you plug it into the equation to find the other. This second step is a little bit crazier because they're in standard form. So I'm going to take y and either put it 3 and put it here or here. I'm just going to use the top equation. So I'm going to say 2x plus 3 times y, which I just found to be 3, equals 11. Now watch. You want to know the biggest mistake you might make? You're going up here and you're using the first equation, but when you go to write this, you write 13. Wrong automatically. Because you're not using this equation. You're using this equation. So you have 2x plus 9 equals 11 minus 9. And I'm really going to be flying through the second part here because this was like October. We've been solving equations like this for a long time, and you should be doing them rather quickly. So elimination, really not bad, is it? Okay, that's the gist of it. So we're going to obviously build on that, and it's going to get a little trickier each time. So you know what to do now. If you have an equation like this, x minus y equals 2, x plus y equals 10. Before today, you would probably go, I'm going to solve this equation for x. I'll add y to both sides. I'll plug it in the other equation. Heck no. You know what you're going to do? First thing you're going to do is see if it's, air quote, ready. Is it ready? Yeah. This is ready because I have a positive y and a negative y, and they cancel each other out, which leaves me with 1x plus 1x and 2 plus 10. And I know my x within a matter of seconds. Are you with me? And when I know one, I can very quickly find the other. If x is 6, what would I have to add to 6 to get 10? 4. Done. Elimination is pretty awesome. Okay? So easy. Okay, it gets a little harder. Okay? So this, by the way, is section 7.3 in your book. And then we're going to learn 7.4 tomorrow. So they do break it up into 2 different sections in the book. So you know the section tomorrow is going to be a little bit trickier. Okay, that's what we call level 1. That's what we call using addition. Okay, now I'm going to give you another problem. And you're going to be able to look at it. And you're going to say, okay, it's not exactly like the one we just did, but it just looks a little different. So if I were to say 4x plus 3y equals 2, and 5x plus 3y equals negative 2. The first thing I notice, and by the way, when your constants look like they're ready to cancel, total coincidence. I don't want to eliminate the constant. That wouldn't do me any good, because then what variable would I solve for? I always want to eliminate one of these. So the y's look pretty promising, except 3y and 3y don't cancel. They give me 6y. One of those needs to be a negative, right? So what could I do? I don't want to go jump right to adding them. What if I subtracted them instead? Meaning, do that. What does doing that mean? It means when I subtract something, I have to distribute that negative first, don't I? And what does distributing a negative do? Changes the sign of everything inside, which would be pretty darn convenient, because if that 3y was negative, I'd be ready to go. So I'm not going to add them right away. I'm going to subtract them. So you know what that's going to do? It's going to create a new equation here. That's a negative 5x, a negative 3y, and a positive 2. And then I might just want to bring this other equation over just to kind of, so they're above each other. Do you see what I just did? I didn't add them. I subtracted them. Okay? And now that I subtracted them, are they ready to go? I hate air quotes, but I do it a lot in this lesson. It's ready now. Okay? And so now I can officially add them. And why do I want to add them now? Because my y's are completely eliminated. Is everybody okay with that? All right? So then what does a 4x and a negative 5x give me? And 2 plus 2 is 4. Divide by negative 1. I have found that my x value is negative 4. And you know what to do to find your y value, right? I'm going to plug a negative 4 in any of these 3 equations. By the way, I could use the original one or this one. Okay, so I'm just going to use this one here. I'm going to say 4 times x plus 3y equals 2. I am cruising through these on purpose. Add 16, add 16. 3y is then equal to 18. It is almost May. We're flying through our equations. Okay, negative 4 comma 6. Good. So then, if I were to have this problem here, x minus y equals negative 4, and x plus 3y equals positive 4. It's just a coincidence that those are. Do I want to jump right into addition? If I were to highlight something, are they ready? Not quite. The x's look promising though, so I don't want to add them yet. I need to subtract them, which means I'm going to put the second one in parentheses. Actually, you could put the first in parentheses too. It doesn't matter. And then distribute this to create a new equation. Don't forget to change the sign of everything. And then if that is bothersome to you, you know what, some people when they write it above this one. So that they're lined up and they just don't have to rewrite this one. So you could put it here if you want. You could put it above it. And now this one's done. And then you could just add from there. So maybe instead of putting it next to it, it doesn't matter. But now are they ready to add? Yes. So my x's are going to completely cancel. That leaves me with a negative 3y plus a negative 1y is negative 4y. A negative 4 plus another negative 4 is negative 8. Am I going too fast? Are we good? Negative 4. And once I have one of my values, I know what to do to find the others. Okay? Take that y value, which is negative 2. Be careful. If I'm going to put it in this one, I better watch because it says to subtract y, which is the same as doing what, really, with a negative. So this is going to be x plus 2 equals negative 4. Subtract this. Actually, no. Where are we at with that? Yep, I put it in front of that. I put the negative there. I knew something was wrong because it wasn't checking. So this is positive 2. Thank you for those of you who are looking around. Now you're subtracting this. X minus 2 equals negative 4. And when you add 2, that's where you get your x value of negative 2. I had negative 2 in my head. I just had the wrong one. Okay, pretty easy. That's as hard as that's going to get for right now. So there is one other type of problem that you're going to have to do. And let me show it to you now. All right. If I said 8x minus 4y equals negative 4, and then 4y equals 3x plus 14, you might look at that and go, well, that doesn't look like the other two she just showed us. It's because it's not. But can you make it look like the other two? Pretty easily by just doing something with one term? Yeah. So I need you to know that every problem we've done so far line up. Meaning the x is lined up, the y is lined up, and the constants lined up. Meaning both equations were in standard form. Well, this one's okay, but this one's not. The y is not lined up with the x. This x is on the wrong side of the equation, so how do I fix it? The 14's fine. I just subtract 3x from both sides, and then you know what I want to do? I'm going to rewrite this new equation above this one, because this one's going to be done in a minute. I just want them lined up. So I'm going to put my equal sign here. My 14 was in the right spot. My 4y was even on the right side of the equation, but it was kind of in the wrong spot, so I'm going to line it up with my y. And then this negative 3x came over, and I'm going to line it up with that. I am then going to cross out the rewritten, or the equation that I don't need anymore. And now I'm ready to add, and then I just look at it as, now do I add them or subtract them? I'm going right to adding them because it's ready. So then I go ahead and say, all right, I'm going to add these. I don't need to change any signs. And so I cancel my y's, and I take a negative 3x and a positive 8x, and I get 5x equals 10 divided by 5. And my x value is 2. Elimination. Thumbs up, yes. Way better than substitution. Heck yeah. So I get the substitution out of the way first because it's kind of a pain in the butt. This is so much easier. So now that I know that x is 2, I'm going to go ahead and just plug it in right here. So I have 8 times 2 minus 4y, 16 minus 4y, and we fly from here. Okay, got it? So that is solving with elimination using addition and subtraction. Tomorrow we're going to solve with multiplication.